What's the difference between Kc and Q? Well, Kc is the equilibrium constant, and it involves the concentration of the reactants and products at equilibrium. The clue is in the name. Whereas Q is the reaction quotient, and that involves the concentration of reactants and products when they're not at equilibrium. Unfortunately, the clue isn't in that name. So let's look at a graph of the Haber process as it approaches equilibrium. You can see that there are three lines there corresponding to the three reactants and products. The concentration of hydrogen is decreasing as the reaction proceeds, as is the concentration of nitrogen. But the concentration of ammonia is increasing, all of them on their way to equilibrium. Let me write out the Kc expression for the reaction, and it looks like at 40 seconds the concentrations are unchanging, and so we are at equilibrium. Now it looks like the rate of reaction is also zero, because the gradient of the curve at that point is zero. The gradient being the change of concentration over the change in time. But don't forget, the reaction hasn't finished. We're at dynamic equilibrium. It's continuing. Let's put in the numbers at time 40, which is when equilibrium begins. And that will give me Kc, the equilibrium constant. Now for clarity, I'm ignoring the units. The units video comes up later. Okay, so that's my value of Kc. Now what about at 10 seconds? Now we can't work out Kc at 10 seconds. Kc only applies when we're at equilibrium. So we're going to use Q, the reaction quotient, because we're not at equilibrium. Putting in the numbers. Well, that's good. I didn't want the same value as Kc. Something would have gone wrong otherwise. Now I'm going to work out the values for Q at t equals 20 and 30 seconds off board and summarize them in a table. Now notice that Q is always going to approach Kc. But of course, when Q equals Kc, you're at equilibrium. And I suppose Q no longer makes any sense. Now in our case, as the reaction proceeds, there's more and more ammonia being produced, more and more product being produced. And you can see from looking at the table that if Q is smaller than Kc, which is the case here, then the reaction must be proceeding to the right before it reaches equilibrium. And conversely, if Q is greater than Kc, then the reaction is proceeding to the left until it reaches equilibrium.